Hello YouTube, it's Alexander here, and today I want to talk about an experiment I recently performed where I asked 2,000 people to name a random number from 1 to 100, and basically I wanted to see whether their answers were random or not. This was a long process. It took me about 15 to 20 hours to gather all the data. I ended up being kind of that guy who stood outside the grocery store with a clipboard, asking for people to name a random number from 1 to 100. So that was actually a pretty interesting experience. Some people were definitely not excited to give me numbers. Some people didn't really care. All in all, it was definitely a good experience. But let's dive into the data and see what I found. The first thing I did was I put all the data into one data sheet because I wanted to see basically if you could see a pattern just by looking at the raw data on an individual basis. This is all the data. I can say I personally could not really see any certain pattern. I did color code the data to maybe help it, jump out more at me. But I personally could not see a pattern in this data. So what I had to do is I had to dive deeper and look at the data more when it's combined, which we'll look at next. Okay, here we're looking at the sample set. Basically, I wanted to test here whether the samples were in fact random. So I did this by looking at the first 1,000 people I talked to over here and the second 1,000 people I talked to over here, and basically comparing these samples to see if I could see similarities between the two. My thought process was, if I did see similarities between the two, then the samples were large enough and statistically significant. But if I did not see differences between the two, it could be two things. One, my sample set wasn't large enough, or two, people were in fact random. But as you can see, it looks like they are quite similar. So when I asked the first 1,000 people, I saw an outlier here of the number 7, where 34 people responded with 7 with the first 1,000 people. And that outlier is also apparent over here. You can also see this triple top where 69, 73, and 77 were very commonly answered in the first 1,000 people, as well as the exact same 3 numbers being very commonly said with the second 1,000 people I asked. And then you also see this trough over here and this trough over here with 99 being large for both of them. So it definitely does look like the sample set is large enough and that there is some statistical significance going on here. And just to confirm that, I did run a random number generator for 2,000 numbers from 1 to 100. And as we can see, it does look like this is much more in a channel, whereas the numbers we did naturally, they're actually all combined down here on the right side, is much larger. This random sample set I looked at, the fewest times said a number was 9 when it would expect to be 20, right? If you asked 2,000 people to name a random number, you would expect each number to be said 20 times. So this one was said 9 times, and the most common one was said 33 times, whereas in reality, when we looked at my sample set, the most common number was actually said 91 times, which is a lot more than 20, and the least common number was actually said 0 times. So overall, looking at this, it definitely does look like my sample was statistically significant and large enough. Okay, here's all the data in a more user-friendly interface. Basically what it is it just shows you how many times any particular number was said from 1 to 100. And it can be read as this is number 1, 2, 3, 11, 12, 13. So this would be 66, 67, 68. So basically it just shows how often any number was said, and it is color-coded, so it is a bit easier to read. And as you can see, there are some patterns now that have started to unsurface. When we look at it like this, I would say the most obvious pattern is that the number 1, for some reason, is very uncommonly said. Basically, from 31 to 91, basically is very light. And then also numbers in the 90s are very light. 90 through 98 are very uncommon, and then interestingly, 99 is quite common. But the 4 most common numbers are number 1 at 69, the second most common number is 77, then it looks like 7, and then 73. So this overall just shows you all the numbers, and you can, come up with whatever you want from that. But I think the last interesting thing about this was actually there was a number that was said 0 times, and that number was 93. So it would have been expected to have been said 20 times, considering I asked 2,000 people, but it was said 0 times, and we actually did have three numbers that were only said once. So it definitely does not look like this data was random when looking at it like this. Okay, here we're looking at odd versus even numbers, and as you can see, odd numbers are quite more common than even numbers. 56% of our data set was odd, whereas only 44% was even. Now, this is only a 12% difference, but the way math works, it actually means that odd numbers are 30% more common than even numbers. And I know that is a bit confusing, but just think, if 60% of a class, is boys versus 40%, that means there's 50% more boys, right? Because 60 over 40 is 50% more. So it's just kind of the way the math works out there. Odd numbers are actually quite more common than even numbers, and I actually did run the number, the stats on it, and it appears that the chance of this happening by random chance would be just 1 out of 250 million. So I definitely do think that this is also statistically significant. Okay, lastly, I grouped the data by tens. So this is all the numbers from 1 to 10 grouped together, 11 to 20, 21 to 30, all the way down. And then on this side, it's all the numbers that end in 0, end in 1, end in 2, end in 3, end in 4, all the way down to 9. And again, we definitely do see some statistical significance here. Each number here should have a average value of 200, but we can see that 1 to 10, 60 to 70, and 71 to 80, or 61 to 70 that is, are all overrepresented. And for some reason, 81 to 100 is highly underrepresented. It looks like for some reason people just didn't like to say very high numbers here. And then it's even more exaggerated over here. There is none that is as low as this one. It does look like numbers that end in 1 are pretty uncommon, but the really statistically significant one here is 7. It appears numbers that ended in 7 are almost twice as common to be said as any other number, because like I said, this should have an expected value of 200 and has expected value, or has a value of 380. So that's almost twice 200. So yeah, 7 is highly overrepresented. And I actually did the numbers on this one. Ran a few mathematical equations, and what I found was pretty astronomical. The chance of this happening, well, just to put it in perspective, is 1 times 10 to the 33rd. So basically what that is that is a billion times more than there are stars in the universe, or a million times more than there are atoms in the human body. So basically, unless you think the survey I ran was the most, insanely, lucky, or you could say unlucky study of all time, the conclusion of this study and this number is humans are in fact not random.